We're gonna solve the mock test from electrical. نبدأ بأول سؤال. First question says two resistors 100 ohms and 250 ohms are connected in parallel اللي هم هني, and the combination is connected in series with the third resistor 40 ohms. What will be the value of the combined resistance across the terminal? Already سوينا هاي قبل وايد. It should be very easy at this point. Reduction قاعدين نسوي. When we have parallel, when we have resistance in parallel اللي هم 2 and 3, and then it is going to be resistor 2 times resistor 3 over resistance 2 plus resistance 3. فيساوي 100 ohms times 250 ohms divided by 100 ohms plus 250 ohms. Okay, that in the calculator, 100 times 200 divided by 100 plus 250. Your R23 is equal to 450 ohms. فالحين we simplified the circuit. فبيستوي عندنا إياه هني resistor وهني resistor وهني ال XY اللي عندنا. This is R1 which is 40 ohms, and this is 450 ohms which is R23. Okay, this is how you will reduce when you have two in parallel together. You will combine them and it will become one in series like that مع ال R1. فالحين these two are in series, for R1 and R23 are in series, then series. 40. So how is شو معناته؟ يعني R1 2 3 اللي هو ال total resistance بيكون R1 plus R23. Simple. So it's equal to 40 ohms plus 450 ohms يساوي 490 ohms. تمام؟ فبيبقى لنا بس one resistor X Y. Alright, بيبقى لنا one resistor of 490 ohms. السؤال يقول what will be the value of the combined resistance across the terminals? This is going to be your value of 490 ohms. Okay. سويت أنا في شيء سويته غلط. 100 times 250 divided by 100 plus 250. This resistance is not 450. ما أعرف من وين جبت ال 450. This is 71.4287. Then, my bad. So just a calculation mistake. So this is 71.42857. فهني when you're adding with R2, 71.42857. So your final resistance is actually going to be 40 plus this. So plus 40, it is 111.42857. يعني it's 11.43 ohms. Okay, this is how you will find your resistance across this. A very easy question to start off with. نروح لquestion 2. And question 2 says a platinum resistance thermometer has a resistance of 200 ohms when placed in a 0-degree ice bath. يعني عندنا ال R0 is equal to 200 ohms. Remember the 0 معناته temperature equal 0 degrees Celsius. زين 200 ohms. And 253.81 immersed in a crucible containing the melting potassium. For R, we will call it T because we don't have the temperature, is equal to 253.8 ohms. تمام? What is the melting point of potassium? إذا نروح ل week 1. ناخذ هذا. This is available for you in the formula sheet. just refer to it. زين. These are the formulas you have for this. فلو تلاحظون هني كتبوا لنا حتى alpha 20 is given. So we know that alpha 20 is equal to 0.00392 per degrees Celsius. Okay, alpha 20 يعني at temperature equal 20. This is what this means. At temperature equal 20 degrees C. We'll call it T1. All right. So what do we use? أول شيء إحنا so we can find a resistance. We will use this very first equation اللي هو RT is equal to R0 times 1 plus alpha T. فإحنا we want to use this equation eventually, which is RT is equal to R0 into 1 plus alpha 0 T. زين, this alpha is alpha 0. بس إحنا we don't have this alpha 0. And we don't have the temperature T. فما نقدر نستخدم هالايكويشن. عندنا ال RT اوكي عندنا اياه و R0 عندنا بعد معطينا اياه بس we need to find alpha 0 so we can determine T and they gave us alpha 20. So remember alpha we can find it using this equation. ف alpha 20 will be equal to alpha 0 ما شاء الله صار برا alpha 0 over 1 plus alpha 0 T. زين, and this T is T1 which is our temperature of 20 degrees Celsius. فبنحط 20 already هني. And we know that this is equal to 0.00392 لأن alpha 20 is equal to 0.0392. So now we have to solve for alpha 0. We will cross multiply. Alpha 0 يساوي 0.00392 times 1 plus 20 alpha 0. زين, هذا alpha t, so just t times alpha 0. Alpha 0 is going to be equal to, let's distribute, زين بنوزع 0.392 plus 20 times 0.00392, so 0.00392 times 20 is 0.0784 alpha 0. اوكي, الحين نجمع الالفا زيروز مع بعض فبناخذ الالفا 0 مدي صوب ثاني يعني بيصير الفا 0 minus 0.0784 is equal to 0.00392. this is alpha 0. if we simplify this is going to be 0.9216 alpha 0 is equal to 0.00392. alpha 0 يساوي بنقسم الصوبين ف 0.00392 divided by 0.9216. so alpha 0 طلعناه يكون 0.00392 divided by that is 4.253 times 10 to the minus 3 per degree Celsius. الحين طلعنا احنا الالفا 0. شو اللي نسوي؟ طالما طلعنا الالفا 0 نقدر الحين نستخدم هذا الايكويشن نفس ما هو وعندنا الفاليو فور الفا وعندنا R0 وعندنا RT. ف R0 again R0 is equal to 200 ohms I think كان 200 ohms و RT is equal to نتأكد بس R0 200 RT is 253.8 ohms 253.8 ohms والفا 0 اللي طلعناه الحين is 4.253 times 10 to the minus 3 per degree Celsius. بنستخدم الايكويشن اللي هو RT is equal to R0 1 plus alpha 0 T 1 plus alpha 0 T. اوكي, ف RT عندنا اياه is 253.8 is equal to R0 is 200 into 1 plus 4.253 times 10 to the minus 3 اللي هو الألفا ضرب T. اوكي, فالحين بس نسوي شوية الجبرا ناخذ 200 هني بيصير 253.8 over 200 is equal to كل هذا اللي هني. زين, اللي هو كذي بناخذ ال1 الصوب الثاني فبيصير 253.8 over 200 minus 1 is equal to 4.253 times 10 to the minus 3 times T. Now we divide both sides with this فبيبقى لنا 253.8 over 200 minus 1 all divided by 4.253 times 10 to the minus 3 زين, and this is equal to t. So if we find the value, put that in the calculator. So 253.8 divided by 200 minus 1, all of it divided by 4.253 times 10 to the power minus 3 is equal to 63.25 degrees Celsius. So this is our temperature of the melting point. لأن السؤال يقول هني it's containing melting potassium. What is the melting point of potassium? Since this is melting, it is at whatever temperature that this resistance is at. Okay? But the answer is 63.25 degrees Celsius. All right? Any questions so far? خلنا نشوف ما كنت قاعد اقرا اسئله. Are we required to draw? هو انا I would recommend you draw. ما اظن you are required, بس if it makes it easier for you guys to solve, just draw it just in case. اقروا السؤال. If the question says what will be the value of the combined resistance, you could just find the value if you know how to find it, but you have to show some steps at least. All right? You don't necessarily have to draw this, but I would recommend you guys draw it if you know it. تمام? This is the first two questions. So far so good. الحين هذا السؤال question 3 that looks scary as it is, but again nothing to be scared about. إنزين. So find the number branches, loops and nodes in the given complex circuit. You must show them on the circuit. إنزين, this is very easy. بس معطينكم circuit شكله معقد كذي resistor هني وبعدين عندكم resistor هني. alright, بعدين عندكم resistor هني, resistor over here, so I have a resistor here as well, resistor هني هالصوب, عندكم resistor داخل هني. زين, عندكم another resistor هني, عندكم resistor هني, عندكم battery over here, another resistor over here. نسيت بطارية ثانية هني. so هني عندكم resistor, بعدين متوصل في بطارية هني. خليني أتأكد مرة. أوكي. عندنا بعدين هني بطارية like that, another resistor, وبعدين عندنا في النص حطلنا resistor كذي. Okay, I think that's pretty much all of it. انزين, فالسؤال أول شيء يقول find the number of branches, loops and nodes. أول شيء خلنا نشوف إحنا nodes قبل ما نشوف أي شيء ثاني, because that will simplify everything. So nodes are going to be in green. عندنا node هني, عندنا node هني. A node is basically any point قبل أو بعد any specific component of the entire circuit. فهني عندنا بطارية, بيكون عندنا node بعد البطارية. بعده بيكون عندنا node هني that is combining all three. A node is basically anything that has a specific voltage. يعني إذا تعرفون هني بيكون في voltage أو مسامحة. My father came in thinking we are dying كالعادة لأن في إعصار برا. خلوني بس أكمل وياكم. عندنا هني نفس ما قلت النود is any point between two components. تمام. فعندنا component هني resistor، بين الريزستور والباتري بيكون عندنا نود، بعد الباتري بين الباتري والريزستنس بيكون عندنا نود. basically any point any line اللي بين two components اللي عنده specific voltage that they call a node. زين. فعندنا هني نود، بعدين بيكون نكمل هني نود، هني there's another node، هني there's another node، this is another node، this is another node. Between the battery and the resistor is a node. هني and this middle point is a node و this point is a node. فبما معناه any point, any two wire connecting two things, that is a node. Okay? And that is what is meant by a node. تمام؟ نكمل الحين ويا loops. Loops is very simple. Loops is basically anything that is closed off. Loops is this, and this. Okay, these are all considered loops. Any closed off places هذا اللي يسمونهم اللوبس. آخر شيء عندنا هما البرانشز. البرانشز بيكون عندنا branch الحين هني بين النودز any two nodes connected that is one branch. between two nodes is one branch. فمن هني لين هني this is our first branch. إنزين. بعدين عندنا من هني let's change the color. branches. Okay. فعندنا من هالنود لهالنود this is our first branch. Okay. بعدين عندنا هني بعد هالريزستور this is a branch. alright. Okay. بعدين عندنا من هالنود لهالنود this is another branch. بعدين من هالنود لهالنود this is another branch. بعدين from this node to this node this is another branch. Okay. بعدين from this node to this node this is another branch. From this node to this node another branch. Another branch. Branch يعني anything between two nodes is a branch. Okay. branch هني، branch هني، branch هني، branch هني فوق، branch هني، branch هني between these two nodes. بعدين عندنا هذا البرانش اللي هني، عندنا هذا البرانش اللي هني. alright. So we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. في branch بعد مضيعنا between two nodes. So this is a branch, 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 this is a whole branch, this is a branch, this is a branch, this is a branch, branch. Yeah. هذه هم كل البرانشز اللي عندنا إياهم. عندنا 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 branches. ما أعرف وين طلعوا 16th branch بصراحة. But these are the branches that I can see. Maybe I have missed one somewhere. But basically branches are the points that are between the two nodes. زين. battery. Okay, thank you very much. That's why I am missing branch. فهني في بعد battery معناته هني في بعد an extra node. So this is going to be a branch هني وبرانش هني. زين. الفكرة بالضبط لا تدققون. انزين هو لازم تعرفون وين النودز وين اللوبس وين البرانشز. النودز هو a point between two branches تقدرون تفكرون فيها، والبرانش is a point between two nodes. انزين a line between two nodes. That is what is a branch and that's what a node is. A node بيكون available at all the different voltages اللي هو يعني after every resistor between every two component there is going to be a node. واللوب هو where it is closed off يعني وين كامل متسكر. فهني متسكر بروحه هاي لوب، هني كامل متسكر بروحه لوب، والهني اللي تحت متسكر بروحه لوب. شكله معقد بس very straightforward the idea. تمام. Moving on to an actual question now finally. Moving on لأن الحين هذيلا these should be free marks يعني بصراحة. Okay. Apply Kirchhoff's Kirchhoff's voltage law in the circuit below to find the current I. Can we join two loops and make the third one? How do you join two loops? يعني هني هذيل اللي تحت you make it one big loop. You cannot technically you can انزين technically you can okay but after you are doing reduction to the resistor in the middle. انزين يعني الريزستور اللي تحت اللي في النص هذا لو قدرتوا تشيلونه and you reduce it to any other circuit you can make this as one big loop. okay but now just stay with the basics. Anything that is closed off is one loop. انزين anything that is closed off is just one loop. يعني تقدرون تحسبون السيركت كامل كلوب مثلا. اوكي بس هو المقصد من السؤال اللي هم الانر لوبس هذيله. تقدرون تحسبون الاوتر that is not wrong ولكن as long as you are already involving the inner loops that is enough, that is sufficient. You shouldn't go and mention the rest. ليش؟ لأن الاوتسايد loops أصلا ما بيساعدونكم في شيء. هو الانسايد loops اللي قاعدين يساعدونكم عشان you determine current or determine voltage or whatever. فأنتوا بس فكروا فيها اللوبس اللي متسكرين يعني the places that are closed off. لأن technically إذا شفتوا اللوب فوق هني كامل this loop is basically this plus this loop فينقسم إلى لوبين. اوكي فنفس الفكرة بالضبط. So just focus on the inner loops. تمام. Now apply Kirchhoff's voltage law in the circuit shown below to find the current I. زين KVL very simple. Let me just redraw the circuit in my own way. فعندنا هني circuit plus minus هني عندنا resistor plus minus resistor resistor plus minus resistor. زين فالريزستور هني 2 كيلو اومز عندنا هني بلس ماينس فولتج. اوكي بلس وماينس فولتج. خليني I color code our plus and minus. زين عندنا فولتج هني عندنا هني 3 كيلو اومز ريزستور هني عندنا 2 كيلو اوم ريزستور هني عندنا 3 كيلو اوم ريزستور. حلو عندنا بعدين 12 فولتس هني عندنا هني 6 فولتس. تمام فعندنا الحين all our components all the values. Let's look at polarity. فأول شيء عندنا هني plus minus مال البطاريات. زين البلس minus مال البطاريات the larger side is always plus and the smaller side is always minus. okay it's always negative كذي. والحين we look at the resistors. First off we need to know the current direction. في السؤال already حاطين لنا إنه we are going to take current in this way. So current is given to us to be like that. فمعناته it's going like this throughout the circuit. This is current I. زين this is how it's going throughout the circuit the current. تمام فالحين we can put the polarities the assumed polarities على الأقل نقول لأن إحنا مو متأكدين إذا هذا الدايركشن صح ولا لا ولكن based on our assumption we are going to put the polarities مال كل الريزستورز. فanywhere the current is going in هني بيكون positive. any point where current is entering a resistor it's going to be positive. فهني positive هني positive and هني positive. anywhere it is leaving the resistor it's going to be negative 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 and negative. تمام this is how you will always put your polarities depending on the direction of current. anywhere it's going in positive anywhere it's leaving negative. تمام الحين we apply KVL خلاص حللنا السيركت بالكامل. let us do KVL. So I'm going to bring the circuit down here and make it smaller just so we can refer to it. what is KVL? KVL basically means that V total زين has to be equal to 0. okay يعني total voltage is sigma V I should say sigma V is equal to 0 يعني the sum of all the voltages across has to be equal to 0. when نقدر we start from any point you want on the circuit and we will go make a full loop until we calculate the voltage of everything. The rules here that apply is this. إذا عندنا بطارية كذي زين current is going like this وبعدين بيكون عندنا بطارية كذي بعدين بيكون عندنا resistor زين current let us assume current is going in this direction for all of these three components. okay هني our polarities of a battery are always fixed plus minus plus minus of the resistor, it's where the current is entering. Oh, it's positive, and where it's leaving is going to be negative. Okay. Just let me take this a bit further away from the circuit. فهذا الريزستور اللي عندنا اياه. زين. فعندنا battery in two different ways they might be arranged, اللي يكون positive negative او negative positive when current is going through it. تمام. ف اول شيء we need to know if this is positive or negative. So remember, when current is going through من positive ل minus, هاي معناته voltage drop. فمعناته this will be negative. Okay. Let me actually put it in black. So this is negative. When it goes from plus to minus, it's negative. Here it's going from minus to plus، قاعد يرتفع، قاعد يروح فوق. فتقدرون تفكرون فيها شيء في البطارية. فقاعد يروح من الكبير للصغير، فقاعد ينزل، فقاعد يستوي نيجاتيف. هني قاعد يروح من الصغير للكبير، قاعد يستوي positive. Current through a resistor is always going from plus to minus, so it's always a voltage drop, so it is negative. تمام? So this is how you will put your signs when you are doing KVL. When it's going from plus to minus, negative. When it's going from minus to plus, positive. Okay? Decreasing, increasing. Voltage drop, voltage gain. Okay? This is how you would think about it. So now let's look at the actual circuit and solve. We can start from any point we want. And then let us start from this top point over here. من the top left of the circuit. Okay? مو مهم where you start, it doesn't matter, بس أهم شيء إن نرجع له. فبنروح أول شيء ل 2 kilo ohms. Before we start, so we know that KVL is equal to sigma voltage equals 0. صح? The total voltage has to be equal to 0. We know that voltage is equal to I times R, current times resistance. وفي هالحالة هني current is the same for all cases. Current is just I لأن they're all in series, so it has all the same current. Okay, this is the whole idea of KVL. It is you have a series circuit, so you can use KVL to analyze the entire current of the circuit. ف V equal IR. فخلنا احنا نشوف أول شيء شنو عندنا هني. بنروح يمين plus to minus, so this is going to be minus I times R. شنو R? 2 kilo ohms, which is 2000 ohms. Again, I repeat. احنا we're looking at this. خليني أكبر شوي. احنا we're looking at this top resistor الحين. We're going in this direction, okay? Our analysis, we are doing it in this direction starting from this green point. فبنروح من البلس للماينس, that is a voltage drop. Voltage drop هني V is equal to IR. So it is minus I times R. تمام? Minus I times R, which is 2000, and I is just I. الحين نروح للnext point هني it's a voltage drop again from a battery. لأنه it's a battery, so it's just volts directly, so it's minus 5 volts. بنكمل another resistance, so بعد minus I times R. شنو R? 3000 في هالحالة. I times R, which is 3000. Okay. زين نكمل نروح تحت لين هني. We're going from plus to minus, معناته again voltage drop. We're going from plus to minus, from the big to the small, so it's going to be minus 6 volts. Plus to minus بعد مرة minus IR. Resistance هني 2000 ohms. Remember, when you have kilo ohms يعني 2k ohms basically is the same as 2000 ohms. So you cannot leave it in kilo, you have to deal with ohms when you are dealing with the units, okay? So you have to convert it all into ohms. Moving on, plus to minus again, so this is going to be minus I times 3000, which is 3000, or 3k, which is 3000 ohms. Here we're going from minus to plus, so it's going to be a positive number, لأن we are gaining. We're going from small to big. Plus 12 volts. ورجعنا للpoint الأخضر فخلصنا الحين الحسبة, and this will all be equal to 0. Okay? So if I just make this a little bit smaller عشان أكفي الإيكويشن كله في خط واحد, this is what it will look like. Alright? This is what your equation now will look like. تمام؟ فعندنا الحين all of these variables, all of these values, and only one variable, which is I. فالحين we can just simplify this equation to determine what our I is. So we have أول شيء to simplify this, look at all the voltages without an I and simplify them together. إنزين هذا أول step. فبيكون عندنا minus 5 minus 6 plus 12. Minus 5 minus 6 plus 12 is 1. طلعنا الفولتج is equal to 1. Okay? Minus I times 2000. And then so I times 2000, I will add in the i's in a bit. Minus 3000 minus 2000 minus 3000 equal 0. Okay? These are all multiplied by I. Same thing again, we can simplify all these values that are multiplied by I together. فبيسوي 1 minus 2000 minus 3000 minus 2000 دقيقة هنا كتبتها غلط بالعكس. This is minus I times 2000. إنزين minus 2000 and minus 3000. Again, we're just combining all the i's. Again, same thing here. This is minus I times 3000. Okay? فبيطلع لنا 1 minus 10,000 I is equal to 0. And now we just solve for I. So 1 is equal to 10,000 I. We divide both sides by 10,000. We are going to get that I is equal to 1 over 10,000 amperes, which is equal to 10,000. It's going to be 10 to the minus 4. Yes, so 1 times 10 to the minus 4 amperes. Remember, if you want to convert this into milliamperes or على حسب السؤال يقول لكم بس find the current, so you don't have to necessarily convert it to milliamperes. But it's mentioned find the current in milliamperes. How you're going to do it? You're going to be multiplying by 10 to the power of 3 to find it in milliamperes. زين? So it's equal to 1 times 10 to the minus 1, which is just 0.1 milliamperes. All right? If you put this in the calculator, automatically بيطلع لكم 0.1 milliamperes. Good? Easy? Then these are all technically considered يعني short type questions. These should be solved very quickly or relatively quickly. Let's go to oh, okay, this has part A, part B, and part C as well. يعني this was part A, what we just solved. زين دقيقة. Part A was asking كان في السؤال it was saying law in the circuit to find the below current. We found the current. Part B is asking again هاي نفس السؤال لا اي نفس السؤال. انزين the total current of the circuit is equal to 0.1. انزين I don't know why they're asking this question again. So the total current of the circuit is just the same thing, which is equal to I is equal to 0.1 milliamperes. That is your total current. لأن عندكم بس one current هنا. زين it's in series, so it's one current. تمام. So again, I have no idea what's the point of this question. This is for a different question بس حاطينه هني ما أدري كيف. تعال خذ. So I don't know what these questions are a part of, but they were put here in this sample for no reason. زين. So we'll just move on to the questions after that. يعني هذه لنا you have IR1, IR2, IR3, IR4, so it's for a different circuit. Let's look at this question, question 5. Maybe this is for this عيال. Maybe. I'm gonna assume that this is for this. Maybe أنا مضيع شوي. إنزين. Yeah, I think that's for this. إنزين. Let us solve this question now. We're going to look at the rest of the parts later. Let's go start with question part A. Okay. In this series parallel circuit shown below, the switch S is closed. Determine the following. يعني هني عندنا switch. It was just going to be a closed circuit and it will be running properly. So they're saying find the total resistance of the circuit. Again, the method you will do here for this one is you're going to do reduction of the circuit. فأول شيء, the first thing we're going to look at is these two resistors over here. إنزين, these two are in parallel, so we know that R3, R4 are parallel. إنزين, so it's equal to R3, R4 are parallel. شو معناته؟ معناته we are going to find R34, which is equal to R3 times R4 over R3 plus R4. Okay? Which is equal to R3 is 250, R4 is 10. So over 250 plus 10 يساوي 250 times 10 divided by 260, 9.615 ohms. إنزين? This is the first resistance that we have reduced. So now the circuit is going to look like this. We have a resistor here. We have a resistor here. إنزين? هنا عندنا بطارية in this way. Okay. This is just ground. And now we're just going to have one resistor over here. Oops. One resistor over here. Okay. This is now our new circuit. This is R34 اللي تونا طلعناه, which is 9.615. This is ohms, and this is R2, which is 100 ohms. R2, which is 100 ohms. Well, this is actually this is, yeah, R2, which is 100 ohms, and this is R1, which is 40 ohms. And then a battery هني plus 5 volts. Okay, so the first step was reducing the parallels together. Now let's look at the next part. هذيل are 2 points over here. They are also in parallel. فبعد R2 and R34 are parallel. So we're going to do the same thing again. So R234 is equal to R2 times R34 divided by R2 plus R34. All right. So it's equal to R2 is 100 ohms and R34 is 9.615 over 100 plus 9.615. So it's going to be equal to so 100 times 9.615 over 100 plus 9.615. It's going to be equal to 8.772 ohms. All right. So this is now our second equivalent resistance. And we can now redraw the circuit again here. بيكون عندنا البلس 5 volts. زين. Going here. هني عندنا resistor. وبيبقى لنا الحين, since we combine these two, they're just gonna be one resistor over here. بيبقى لنا الcircuit كذي. This is our R234, which is equal to 8.772 ohms. And this is R1, which is equal to 10 ohms, 40 ohms. Okay. So now the last two that we're going to analyze are these two. Then these two are in series. So R1 and R234 are series. The series is very simple, very straightforward. All we're going to have to do is add them all up together. Our total, since this is the last two resistors, our total is going to be equal to R1 plus R234. So it's equal to 40 plus 8.772, which is our total is now equal to 48.772 ohms. Okay, this is our total. So that's the part A. We are done with part A now. We have solved that. Let's move on to part B. Okay. Part B says, find the total current of the circuit. So again, total current is simply what? First of all, this is V is equal to IR. Therefore, I is equal to V over R. This is the equation we are using. But in this case, we want the total current. So we have to find the total voltage, total current, total resistance. So total current is equal to total voltage over total resistance. We found our total resistance, and we only have one voltage source of 5 volts. So this is our total voltage. So this is equal to 5 over 48.772. So IT is equal to 5 divided by that, which is كيف جي giga 48.772. 5 divided by 48.772. طلع لي okay 1 or 0.125 or 1025 بس amperes. Okay, 0.01025 amperes. زين. Again, if the question asks, you don't have to necessarily do this, but if the question asks to find it in milliampere, you will multiply by 10 to the power 3, so you can find it in milliampere. This will be equal to, just go into the calculator, your answer multiplied by 10 to the power of 3, وبيطلع لكم 102.517, which is 8 rounded up, milliampere. Okay, that's it. That's what you're going to be doing. Moving on to the next question, part C. C says find IR1, IR2, and IR4, meaning if we look at our initial circuit, we have we have current going through everything. So let me copy paste the initial circuit again. So this is our initial circuit. Let us now analyze it. So we know that current, طلعنا الحين الكرنت من هني. All right, current goes from plus, okay, and comes back into minus. That's what we are assuming. All right. But actually, this is what it is because this is the only voltage source. The current has to be flowing in this direction from here. All right. But keep in mind that this current now is going to be split into parts. لأن هني we have a junction. يعني there's more than 2 points. So the wires are split into 2. So we're going to have another current going here. We will call this I2. Then we have another current going here in this direction. Then again, we are going to have another current going here. We will call this I3. Then again, we're going to have another current leaving from there. We're going to have current here. Remember, the switch is closed. Okay, so we have current going through here, here, and it will come back in here. So these two will combine again. So we're going to have the same current going back as the top that's going in. وبعدين it will come back into this, and this is what it looks like. All right. These are the currents that we have. So we have I2, I3. We'll call this I total, which is the same as I1. So the current through resistor 1, you know directly it is equal to I total. So IR1 is equal to I total. All right. Why? Because it is the same current that is going through it. زين هني عندنا I4. Okay. السؤال كان يقول لنا اصلا لازم نطلع IR1. So IR1 is IT I total. So IR1 is I total. So it's equal to 0.1025 amperes. طلعنا IR1 directly. الحين let's look at IR2. Let's look at our voltage. Remember, we have only one voltage source. Okay, so our voltages are going to be changing only when it goes through R1. فيعني when it goes through a component, the voltage is going to change through that component. صح؟ let us analyze it in that way. How can we do that? So we know that the voltage here is 5 volts. Then let us put our polarizations for everything. So this is plus minus, this is plus plus plus, minus minus minus. Again, the current, we are just assuming their directions. Once we find the actual value, if it's negative, we just know it's in the opposite direction. Okay, so this is the polarization for each one. فالحين احنا we want to know the voltage at in this line over here. We want to know the voltage that's over here in this line. Let me actually just use the highlighter. We want to find out the voltage here, because we know that this voltage all over here is the same. صح ولا لا? We know that this whole voltage over here is the same. We'll call it voltage V. We don't know what the actual value of it is. We just know that it's V. Okay, we'll call it V, and we'll consider the bottom part our ground. زين? So we are gonna ground here. هني, this is our ground. V0 equal 0. تمام؟ معناته هني عندنا 0. So this has to be 5 volts in this line over here. This is 5 volts. All right? Because this is our ground. All right? This is all our ground over here at the bottom. This is our ground. زين? So we have 3 voltages. We know 2 of them. We just need to find the third one. Easy. Remember that voltage across this. زين? يعني we can, how can we do this? We can say that voltage V1, which is 5, minus this voltage over here, which is V, which we don't know, over this resistor R1, which is 40 ohms. This is equal to I1. صح ولا لا? لأن the current, this is just V equals IR. But remember, when we want to find voltage, we are always going to do the plus, subtract the minus. Okay, so plus side is 5, the minus side is V. So 5 minus V over 40 ohms is equal to I1, which we already know is 0.1025 amperes. So now we can find this voltage here, so we can determine the remaining currents and everything else. So 5 minus V, if we just simplify this equation, this is going to be 5 minus V is equal to 40 times 0.1025. Okay. And now the V is here. This is purple, V. Okay, so now we just take the 5 to the other side. So it's going to be V is equal to 5 minus 40 into 0.1025. Don't get confused. All I did is I swapped places. That's all I did. فيعني I took 5 minus this. I took the V to the other side, and I took the 40.1025 to this side. Best, all right? So it's just basic algebra. 5 minus 40 times this. We put this in the calculator. We can determine our V. 5 minus 40 into 0.1025. 5 minus 40, this is 0.1025. Okay, this is 0.9 volts. It's just making sure. Again, 0.1025. You have to assume your ground. Yeah, it's 0.9 volts. You have to assume your ground to be somewhere, or else it will be very difficult to solve such a question. Not just difficult, you won't be able to solve a question. You have to assume where your ground is. لأن if we don't assume the ground here is 0, we don't know what this voltage at the bottom here is, so we're not sure if the voltage at the top here is 5. فدايما assume the location of your ground. So when you assume the location of your ground, you can assume that this whole voltage is 0. تمام؟ يعني أنت كيف تعرف ارتفاع البناية مثلا 200 متر؟ ارتفاع البناية ليش 200 متر؟ 200 متر من الأرض. ما تقدر تقول بس شي 200 متر من ولا شيء. لا، هو من الأرض. That's why the same idea with voltage, you have to have a specific place that you are grounding in the circuit, that you are considering your 0 point. All right? Now, so 0.9 volts. Now we found our voltage V to be 0.9 volts. We can find the current that is going through each and every single one of these resistors using V equal IR. Remember, again, all I did here was V is equal to IR, and I rearranged it into this form where I found the voltage before minus the voltage after. That's it. That's all I did, and we're going to be doing that again now here. Let me just copy paste this down somewhere. So, then, so now let us continue solving for each and every single current. Okay, so R1, we have already I1, we found it. We need to find I2. How can we find I2? I2 is equal to V over R. شنو ال V over R? V is the voltage from plus to minus. In this case, our plus is the V, and our minus is just V0, which is 0. Okay? لأن هني الماينس, I'm looking at R2. The plus side, it's V0, it's V, I mean, and the minus side, it's V0. So it's V minus V0, which is just 0, over R2, which is 100 ohms. And we know that V is 0.9 over 100. So I2 is equal to 0.9 divided by 100. 9 times 10 to the minus 3 amperes, or in milliamperes, it is 9 milliamperes. All right, it's the same thing, just multiply by 10 to the power of 3. Okay, so we found out our current 2. Let's find out our current 3 now. Same exact idea. I3 is going to be equal to voltage V, which is 0. I'm just going to write it down again. V minus V0. We're going from positive to minus. All of these, the positive to minus, it's from going from voltage V to voltage V0. And V0 is just 0. Over, in this case, the resistance is 250. So it's equal to 0.9 over 250. So it is 0.9 divided by 250, which is I2 is equal to 3.6 times 10 to the minus 3, or you can say this is an amperes. You can say this is 3.6 milliamperes. All right. And finally, I4. I don't think they were asking for all of the I's. They were just asking for R1, R2, and R4, but we might as well solve for all of it. We have I4 now. Again, the same idea. I4 is equal to V minus V0. V0 is just 0 over the resistance of 10 ohms, so it's equal to 0.9 over 10. So I4 is equal to 0.09 amperes, or if you want it in milliamperes, it's going to be 90 milliamperes, just multiply by 10 to the power of 3. And we have now found the current of each one as the question has requested. The currents IR1, IR2, IR3, and IR4, we have found it. Now this is an interesting question. If the switch S is opened, find the new R total. And then when we open this switch, if we look at the question again, when we open the switch, okay, current is no longer flowing in this direction. There is no current, okay? So what happens? We basically remove the circuit completely. Since the switch is open, there is no current. Then the current will always travel through the shortest route possible. هني we have an open switch, so current will never go towards that لأن هني مقطوع الواير. كأنه مقطوع. So this whole part is now completely removed. So you are remaining only with this circuit. So the question was, if the switch is opened, find the new R total. All you have to do is analyze the circuit we have. So this is going to be plus minus resistor here. And these two are in parallel, and you're going to have a new parallel resistor here. So again, now these two are in parallel. Then these two are parallel, which is R2 and R3. R4 doesn't count anymore, خلاص. So R2 parallel R3. Therefore, it is equal to R1, which is 100, R2 times R3, which is 250, over 100 plus 250. Okay, this is equal to 100 times 250 divided by 100 plus 250. 71.429 ohms. Okay, and this is our R1, which is equal to 40 ohms. These two are in series, so in series to R total, or new R total, this is just our 5 volts. R total is going to be equal to 40 plus 71.429, and it's equal to 111.429 ohms. All right. Again, reduction, we've done it a lot of times. You guys should be familiar with this. Again, when the switch is open, that means ما في current قاعد يروح هني، معناته ما في voltage drop, voltage gain، ما في ولا شيء. يوم current يساوي zero, the circuit is an open circuit، ما تقدرون تستفيدون منه. تمام؟ we will only look at the left side of this and just do the reduction like we did in part 1. Okay? Any questions about this? It was a different question, but same numbers, so we most probably did find something similar in this resistance. Because it was similar, the question, it was very similar, I think, and it was exactly the same number. تمام؟ عشان شي we found the same resistance. مو المفروض اللي شلتها تكون سيريز ويا اللي صوبها؟ هذه اللي شلتها سيريز ويا هذه، how is it in series؟ ما سجاد؟ وضح لي بس سؤالك شوي. اللي هو what we removed مو من نقطة واحدة، في نقطة فوق ونقطة تحت. كيف نقطة واحدة؟ نقطة فوق نقطة تحت قاعدين تلاقون. نقطة فوق ونقطة تحت. الحين we have this point over here and this point over here. They're meeting. For both of them, حتى the previous one, there's this point over here and this point over here. They were meeting. هني صاروا series. هني بس نقطة واحدة. لا هني ما أثر عليه. هني بس فتحنا إحنا السيركت، فتحناه فشلينا هاي القطعة بالكامل. So here they stayed in the same direction. يعني in the same arrangement. They're both in parallel. ما في شيء اللي خلاهم يصيرون سيريز هني في هالحالة. هني تموا in parallel. اوكي. اللي بالأسود. ايه انزين هذا اللي بالأسود. اوكي. خلنا اجيب السيركت بعد مرة. Just so you can see. وين رحت أنا؟ was it this one? Yes, it was this one. وين راح السيركت؟ بسم الله. هذا هو. alright. if we're gonna look at it again. زين. زين. انت قاعد تقول الحين قاعدين تلاقون بس بهالنقطة صح؟ بس هني open، هني ما في connection خير شر. هني ما في connection خير شر. ما في كهرباء، ما قاعد يوصل مكان، ما في voltage drop voltage gain. عرفت قصدي؟ فلأن الحين السيركت هني صار open، فتحنا الواير هني، هذا مو متصل بشيء ثاني. Remember a circuit for it to be a circuit it has to be closed، لازم يكون مسكر. بس أول ما تفتح أنت هني الاتصال خلاص ما يبقى لنا يكون في connection الحين من الصوب الثاني. صح ان هذا الحين متوصل ويا هذا بس at one point، بس الصوب الثاني مو متوصل في ولا شيء ثاني، يعني it is not coming back to the original voltage source. فالكرنت يوم بيوصل لك هني انزين، فرضا نفترض بس، خلينا نقول الكرنت is going into this direction، بيروح لك into this direction، بتشوف هني ما قاعد يرجع، هو الكرنت لازم يرجع للفولتج سورس، بيوصل هني بتشوف انه ما قاعد يرجع الكرنت، فما بيروح هناك، بيكمل هني اللف ماله. فهمت علي؟ فهني بيتخطى هالبوينت لانه ما يقدر يرجع، لان الكرنت ما بيروح لك in a place that is open، ما بيوصل لك مكان وبيطلع، ما في شيء. فكرنت will be like this. هذا البارت كامل بس بينشال. تمام في الاوبن. تمام and this was this question. نشوف السؤال اللي عقبه. ناخذ بس 5 دقائق بريك عشان يجمع صوتي شوي، صوتي بدأ يروح، وبعدين بنبدأ I believe it's mesh وبعدين nodal. تمام 5 minute break and we will do the mesh question and the nodal question. Okay, let us continue and do the mesh analysis for the next question and the nodal for the question after that. So find the current using Maxwell's loop current method, or sometimes it's also called the mesh method. And then, so this is the current we have. Remember, when we are using Maxwell's loop current method, yani loops, we are going to be using KVL. KVL, okay? So whenever we are using the loop method, just remember that we are going to be using KVL. They have already showed us the direction of the current. Let me just redraw the circuit again. So make this a bit smaller so I can draw it in my own way. Mesh معناته KVL. So the circuit is going to look something like this. Resistor here, a resistor here. And then we're going to have a battery over here, or a voltage source, I should say, over here. زين. وبعدين عندنا a voltage source in the middle as well over here, going up. Positive side is at the bottom. Negative side is here. Then we have another resistor like this. And then we have this all connected to each other. This is R1. This is R3. This is R2. Okay. Our currents are given in these directions. So this is IA, and the second one is IB. Right? And we know that this is plus for the batteries, and this is minus for the batteries over here. This is minus, minus. And then the batteries are 10 volts each, so this is 10 volts. This is 10 volts. Resistors, this is 1 kilo ohm. This is 2 kilo ohms. And this is 2 kilo ohms. All right. So when we look at it from the perspective of loop 1, of current 1, IA, current is going basically in this direction, yani. Like that, like that, like that. Okay, current is going in that direction for IA. We're going to put our plus and minuses, polarities, current going in. So this is plus, minus, all right? Plus, minus. And for this resistor, in terms of IA, this is going to be our plus over here. And this is going to be our minus over here. And then, now when we look at it from terms of IB, we have this resistor. Current is going, first of all, in terms of IB, current is going into this direction. Into this direction, all right? If current is going in from here, so this is plus, leaving there that is minus. And for this resistor now, if you notice, the polarity is the opposite. This is our minus because current is leaving from there. And this is our plus because current is entering from here in terms of IB. So when we're doing the loop for the right side, this is going to be our polarity. When we're doing the loop for the left side, this will be our polarity. Tamam? So let us start solving. Like I said, we're going to be applying KVL in the case of current of Maxwell's loop. And this is our circuit. Then, so let's apply KVL for loop 1. So loop 1 or loop IA. Okay. Let me bring this a bit lower. Okay. So loop IA. ما أعرف ليش كاتب KVL الكبر هني خله هني. This is loop IA. Let us start solving for it. So KVL, just remember what was KVL. KVL means sigma voltage should be equal to 0. All the voltage should be equal to 0. So we start from one point, reach the end, and come back to that same point. Let's start from here. So again, we're going to be looking through the first loop. So the first loop, we're going from plus to minus onto this resistor. So this resistor is going to be minus IA, negative IA, times R1, which is 2000 ohms. 2 kilo ohms just basically means 2000 ohms. Tamam? And then we will continue again. Now we are going through another resistor. Again, it is going to be a voltage drop. Minus IA. Okay. The way I usually like writing it is this way. So I'll put minus IA times 1000. 1 kilo ohm, which is 1000. But again, here we have two currents. We have a current going down and the current going up. So the current going up is gaining. It's not a voltage drop, it's a voltage gain in its terms. So it's going to be plus IB times 1000. All right? You can either write it in this way, or you can directly just write it as minus IA minus IB. All right, because it's the difference of the two currents. But so to avoid confusion a lot of the times, this is what I usually do it. So I can just follow the rules directly وما أخربط وايد ويا الساينز. And we have the last thing, we have a 10 voltage here. We are going from minus to plus, so it's a voltage gain, so it's going to be plus. So let me just make this a bit smaller. Okay, so plus 10 volts, so it's equal to, now when we reach this, we reach back to our green point over here where we started, it's equal to 0. Let's simplify this a little bit. Let's group up all the IAs together. So minus IA, these are both negative. So it's going to be minus 2000 minus 1000. It is just negative 3000 IA. So negative 3000 IA. Then plus 1000 IB is equal to, we'll just take the 10 volts to the other side, is equal to minus 10 volts. All right, here it's plus, so when we take it to the other side of the equation, it becomes negative. Okay, minus 10 volts. So this is our first equation. We have found our first equation from loop IA. All right, so this is our first equation. Now let us look at loop IB. Again, we're going to apply KVL, and let's start from this point, and we will go in the direction of current. So we're going to go here from plus to minus. So this is a voltage drop. We're going from plus to minus. So it's going to be minus 10 volts. Then again, we are going back here, and now we are going up here. Again, this is plus to minus. So this is another minus 10 volts. Okay, we're going from plus to minus. Now, when we're looking at the middle resistor, we're looking at the right side polarity, which is plus minus over here. So again, this is going to be a voltage drop in terms of IB. So this is minus IB times 1000. But remember, in the middle line, we have two currents. We have currents going up and down. So the IB, it's going from plus to minus, but for IA, it is going from minus to plus. So it is a gain. So it's a positive IA times 1000. Right? And then we are going to this R3. So it's again minus, going from plus to minus. So it's minus IB times R3, which is 2000 ohms, 2 kilo ohms. All right. And this is all going to be equal to 0 since we have reached back to this purple point, our starting point. We have completed the loop. Now let's simplify this. So minus 10 and minus 10 becomes minus 20. Minus IB and minus IB here. So minus 1000 and minus 2000 becomes negative 3000 IB plus 1000 IA. All right. And this is equal to 0. Last thing I'm going to do is I'm going to arrange it so that IA and IB are, IA is first and then IB is second. And the voltages, any constants, I'll take to the right side. فبيستوي لنا 1000 IA minus 3000 IB is equal to, or just the minus 20, I'll take to the other side, so it becomes plus 20 volts. And this is our equation 2 from loop 2. Now that we have these two equations, equation 1 and equation 2, we have two equations with two unknowns, so we can determine the currents finally for both using simultaneous equations. And then you can do it in any method you want, but I usually would recommend you use the calculator if you know how to use it to simplify everything directly. The way to do that is you will do mod 5 1. All right, so using calculator mod 5 1, you're going to get a matrix and you're just going to put the values in the matrix in this order. So minus 3000, 1000, and minus 10. The second row is 1000, minus 3000, and 20. Okay. I hit equal. It will give me X is equal to 1 over 800, which is 1.25 times 10 to the minus 3. And it's going to give me that Y is equal to negative 6.25 times 10 to the power of 3. So this is obviously in amperes. So X is going to be the first value. This is our X. And Y is going to be our second value. This is our Y if you're using mod 5.3. So we know now that IA is equal to 1.25 times 10 to the negative 3 amperes, or simply 1.25 milliamperes. And we know that IB is equal to negative 6.25 times 10 to the 3 amperes, which is simply equal to negative 6.25 milliamperes. Now, since we got a negative value, this doesn't mean it is incorrect. All right. Another way we can write this now is saying IA is equal to 1.25 milliamperes. Okay. And where did we assume the direction? For both, we assumed it clockwise. So if our assumption is correct, we have a positive value. So this is going to be clockwise. Okay. And IB, since it is a negative value, we can say it is 6.25 milliamperes counterclockwise, in the opposite direction of what we have assumed. Counterclockwise, or sometimes they call it anti-clockwise. Then, so now we have found our currents IA and IB, but the question says find the currents in resistor 1, resistor 2, and resistor 3. So if I just take this back down here, and let's fix the polarities of everything now. Okay. So we know that we were wrong about the direction for IB. Let me just make this a bit bigger so I can remove these easily. We were wrong about the direction of the current IB, but it's fine because that was just our assumption. Now we know that this is the direction of the current IB. Okay, and we have found the values of IA and IB. So if I just write them down with their values now directly, IA is, or I'll just make it simple, I'll just write it up here. IA is equal to 1.25 milliampere, all right? And IB, now we know it is going in the counterclockwise direction. So the direction is actually in this way. This is the actual direction of our current IB. So IB is equal to 6.25 milliamperes. Tamam? So we know that IR1 is equal to IA. Why? Because the green current is going through it. And for IR3, it is equal to IB because the, yeah, let's fix the polarities now actually as well. زين. And IR3 is going to be equal to IB لأن only the current IB is going through it. حلو. So we know that IR1 is equal to IA, so it's equal to 1.25 milli amperes. زين. And we know that IR3, let me write it on the other side. So IR3 is equal to IB, which is equal to 6.25 milliamperes. تمام? Now, we are left with IR2. Okay, IR2. So you can either visually analyze this and figure it out, or you can use KCL to figure this out as well. I usually like to just look at it and understand what it means. So if we notice, we're noticing that these two currents are overlapping. They're going on top of each other. So they're both supporting each other. Yani they're both adding up to each other and they're going through IR2. So we know that IR2 is equal to IA plus IB. ليش؟ لأن look at the arrow direction. Since they're both going in the same direction, معناتها this is they're adding up to each other. When they're going to opposite directions, it's going to be one minus the other. All right. So this is basically saying IA plus IB, which is 1.25 milliamperes plus 6.25 milliamperes. So it is equal to IR2 is going to be equal to 1.25, that's 6.5, 7.5 milliamperes. زين. And the directions, you can see the direction of IR1 is going to the right, the direction of IR3 is going to the left, and the direction of IR2 is going downwards because both of the currents are going down together. So now we know that the polarity of this one is plus over here and minus over there. So it's plus over here and minus over here. And for the middle one, we know that the polarity is plus at the top and minus at the bottom because both currents are going in through here. All right. If you want to see a case where they're not, you can refer back to the mesh analysis video that I have done. They go in opposite directions and I explain how you will find out the current over here. If you want to do this through KCL, let's look at this node. This node over here, I'm just going to redraw it, okay, this part. So it's going to look like this. Just a reminder, KCL is Kirchhoff's current law, and it says that sigma current is equal to 0. All right. What does that mean? We know that this is how we have our IB and our IA. So this is IB and this is IA. Okay. So let's call this current that is leaving from here. And then obviously, by the way, since these two are entering, this has to be a current that is leaving. All right. If we know the direction of IA and IB is correct and they're both entering, then this must be a current that is leaving. All right. And we'll just call this IC. So KCL says that all the current that is entering should be equal to all the current that is exiting, or if you're adding all the current together, it is going to be equal to 0. In other words, we're just going to assume a direction. So let's say entering is negative, leaving is positive. All right. So which currents are entering? IA and IB are entering. So we're going to say minus IA minus IB. Again, you can assume any direction as long as you're assuming one for each. So entering, we have assumed to be negative. So IA and IB entering is negative, and exiting will be positive. IC is equal to 0. So if we want to find out current IC, IC is equal to IA plus IB. All right. This is how you use Kirchhoff's current law to determine your IC. And remember, your IC is just the current that is going through the resistor. It's the same thing as I used this equation here, and you're just going to get the same value. Any questions about Maxwell so far? About current, KVL and using Maxwell loop? KCL, I wanted to show you it as well, because we're going to be using the same concept now when we are solving for a nodal. Is this clear؟ بعدكم معاي ولا رجعتوا ولا شو السالفة؟ زين recap inshallah. Let us start again, just looking at it again from the very beginning. So the question wants us to use Maxwell's loop to find the current through all the resistors. First thing is you're going to assume a direction. Since they've already given you a clockwise direction for both, you're going to just take the same assumption that they did. You're going to apply KVL. Then before that, you need to make sure you identify your polarities depending on your current direction for everything. Hello? Once you have determined your polarities, remember the left loop is going to have a different polarity than the right loop for the middle part, and then for the middle resistance. Then we're going to do our KVL analysis for loop IA. So again, this is all we did here is just KVL, then KVL, and KVL. That's all we did. We only used KVL. Okay? So what does KVL say? That the voltage at a node coming back all the way to the node should be equal to 0. The sum of all the voltage should be equal to 0. So we start from a specific point. Entering here, this is a voltage drop. So the voltage drop is equal to V is equal to IR. Remember that. V is equal to IR. Then, so we're just writing I times R over here. IA times the resistance of 2000, and it's negative because it's a drop. And then when we go through the middle, Y minus, لأن بعد مرة. We're going from plus to minus. When we're going from plus to minus, that means we're going to have a negative value. All right. This is the case that we did. Just to recap, KVL in a resistor, you're always going to have it negative when it's in the direction of current. For a battery, if it's going from plus to minus, it is a drop, so it's negative. If it's going from minus to plus, it's positive. Okay, that's it. That's why it is minus in this case, because we have a resistor here. So it's plus to minus, so it's a drop. Continuing on to this resistor, again, plus to minus, so it's a drop. However, in the middle, we have two currents. We have the current from the first loop and the second loop. But since we're looking at it best from loop A's perspective, we're going to be using the polarity from loop A. And then IB in terms of loop A is going upwards. So it's going from minus to plus. معناتها it is going to be a positive value because we are looking at it again from loop IA's perspective. And then times R again. And then we move on. We have this voltage. So this is just a voltage from minus to plus. So it is plus 10. And then we go back to our starting point. Okay. Same thing. Then we simplified this equation. Had an equation. We moved the voltages to the right side of the equation. يعني any constants to the right side. وبعدين بنرتبهم IA و IB on the left side. Again, we did the same thing for loop B. KVL, we started from this point. نزلنا voltage drop from plus to minus. So it's going to be minus 10 for the first value. Then again, over here, we got to here, plus to minus. So again, it is a negative because it's a voltage drop. We're falling from plus to minus, so negative 10. Then we are going through the middle. Now we are looking at this polarity in terms of IB. So this is plus down, minus up. معناته this is a voltage drop again. So it's a negative value of IB times the resistance 1000. Again, we have two currents flowing in the middle. The current IA is in the opposite direction. That's why it is a plus IA. It's going from minus to plus. So it's plus IA times 1000. Then minus over here again from plus to minus. So it's minus IB times R3, which is 2000. And we got back to our main point. So it's equal to 0. Simplified this equation and we got two equations, two unknowns. Okay, we solved the simultaneous equation. I used the calculator. You can do it in any way you like. Once you solve it, you're going to get two values, IA and IB. Notice that in IB, we got a negative value, meaning that the assumed direction initially was clockwise, meaning our assumed direction was the opposite of what it actually is. So we can simply say this is 6.25 counterclockwise or anti-clockwise. So when I redrew the circuit again, I fixed my current directions. Now I know where all the current is going and all the polarities. I1 or IR1, I should say, the current flowing through I1 is equal to IA because it's the only current that is flowing through it. So IR1 is equal to IA, which is 1.25 milliamperes. And R3, it's the same case. IB is the only current that is flowing through it. معناتها IR3 is equal to IB, which is 6.25 milliamperes. The middle, we have two currents flowing. Since they are both in the same direction, معناته the total direction is going to be downwards, all right? The current is flowing downwards, and we're just going to add up these two values of current, which is IA and IB. So IR2 is going to be equal to 1.25 plus 6.25. Okay. All right. Let us do our final question, which is which is the nodal analysis. إنزين. Oops. Mid mark. هني. إنزين. So the final question says, find the magnitude and actual directions of the currents I1, I2, and I3, which they have already given us the assumed directions of, given in the given circuit using nodal analysis. So I'm just going to redraw the circuit again. We have a battery over here. This is plus, this is minus, like that. Then we have a resistor over here. We have another resistor over here. We have another battery over here. This is the minus part, this is the plus. And then these are both going here to the ground. Right? Then in the middle, we have another battery over here. This is the minus, this is the plus. And then in the middle, we have a resistor again. And this is what our circuit looks like. This is R1, which is 2K ohm. This is R2, which is 1K ohm. This is R3, which is 2K ohm, similar to the previous example. This is plus, this is 5 volts. And remember, the batteries, we can instantly just put our polarities from the beginning. This is the plus side, this is the minus side. Then, so the middle one is 5 volts, the left one is 10 volts, and the right one is also 10 volts. Okay? And this is our circuit. They are assuming a direction of I1 to be upwards like this. So this is the direction of I1 they're assuming. So in other words, this is I1. It's going into this flow like that. I2, they're assuming it to be in the middle going downwards. So the direction of I2 is assumed to be in this direction. This is I2. So this is our I2. And finally, we have I3 that is also assumed to be going upwards like that. This is I3. So in other words, it's going like this. Okay, this is our I3. So if you notice here, we have two nodes, or we have a lot of nodes actually, but the way we usually do nodal analysis is we look at the node where there's a three-way intersection. That's how you will do nodal analysis. You will look at a point where you have three different components connected to that same point. So we're going to use this node to calculate our V. Let me use the color red, all right? This point over here, this is where we have a specific voltage that we will assign as V to find out all the currents and everything using the nodal analysis. So this node, as you can see, we only have 3 currents in our circuit. Since we only have 3 currents, we only have 1 node we can use for analysis. If we have 5 currents, we can use 2 nodes. If we have 7, we can use 3, and so on and so forth. All right? Because nodal analysis depends on KCL, and KCL depends on a minimum of 3 currents. Then, so let us get into it. So again, we're going to be applying KCL. What was KCL? KCL means sigma I is equal to 0. All right, that is what KCL means, that all the current entering is equal to all the current that is leaving. All right, and you can assume the direction again. So I'm going to say entering is negative. Entering is negative, right? And exiting is positive. Okay? So here, if we look at this node, I'm just going to draw it again over here, but a bit larger. So if we look at this node, this is our point V. We have current entering from the left, which is I1. This is I1. We have current entering from the right, which is I3. And we have current leaving from the bottom, which is I2. زين? So I1, يعني we know KCL is going to be I1, I2, and I3. And I3. All right, this is what KCL is, and it's going to be equal to 0. So what are the signs? If it's entering, it's negative. I1 is entering, so we're going to give it a negative sign. I2 is exiting, so it's going to have a positive sign. I3 is entering the node, يعني it's going towards V, so it is negative. All right, again, you can assume either way, entering negative or entering is positive, as long as the other one is the other sign. Why not the other way around? You mean for the signs? Again, you can choose whichever way you want. And you can choose it exiting. You can choose that to be negative. All right? Perfect. This is exiting, not existing. Exiting. Okay, you could choose however way you want. You can analyze it yourself. Now, this is our KCL circuit. Right? So it's minus I1 plus I2 minus I3. Let me just copy paste this down here. And make it smaller so we can look at it while we do our KCL analysis. Okay? So, remember, we are looking at node V. All right? This is the node we are doing. And remember, we're doing KCL. And we have already done our KCL equation up here for node V. So, we know we're going to have minus something. I'm going to keep it color-coded. So, minus something which is equal to I1 plus something which is equal to I2 and then I3 is minus again, so minus something that is equal to I3. All right, which we will fill out in a bit. And then minus something that's equal to I3. And this will all be equal to 0. So what do we know? We know that V is equal to IR. صح ولا لا? V is equal to IR. But here we're dealing with current. So we know that I is equal to voltage over resistance. صح ولا لا? Now, how are we going to do this analysis? We're going to look at, again, the polarities. We did not mention the polarities early on. Let us put our polarities. So current is entering from here. This is plus. This is minus. Okay. The resistance in the middle, again, current is going downwards. So this is plus, and this is minus. Okay. That minus is a bit too big. And this is minus. And then for R3, again, the same idea. This is plus, it's where it's entering. And this is minus. All right, so plus and minus. All right. We have now determined our polarities. So we're going to look at our voltage V. We're going to look at our voltage V. And we're going to go to the left and see what's the left of it for I1, because that's where current I1 is. So for I1 is entering. All right. So we have this resistor over here. This resistor is going to be our resistance at the bottom, which is 2000 ohms for I1. Okay. So this resistor is our resistance at the bottom. Remember, it's V over R. All right, V over R. But what is our voltage? Again, remember, voltage is going to be voltage from the plus minus the voltage at here at V. So when we're looking at the plus side, What do we have at the plus side? We have negative 10. We don't have positive 10. We have negative 10. Why? Because if you look at this, this is negative. And then, يعني, let me make this a bit bigger and keep it at the bottom so we can look at it while we work. So, and then, if you look at it again, let me repeat. We have minus 10 over here. Why? Because we're starting from the negative side of this battery, not the positive side. So we have minus 10 minus V, all right? Because this part has a negative 10 volts. So minus 10 minus our V, okay? Because remember, it's the whatever's on the plus side minus whatever's on the minus side. So on the minus side, we have V. On the plus side, we have minus 10 because the polarity of this battery, the negative side is given towards us, not the positive side. And then that is why it is minus 10. Let's look at now current I2. Current I2, again, what's the resistance? It is 1000. All right, 1 kilo ohm or 1000 for R2. Again, look at the plus and minus side. The positive side here, the positive side is V. So we have V. Okay, that is the positive side of this resistor. The negative side of this resistor is also a positive value of 5 volts. Okay, so this is a positive value of 5 volts. So this is going to be plus 5. Tamam? Since the polarity of this is plus towards the up, so this side is the positive 5. Here, the polarity of the minus was up. This is negative 5. All right. Now, going on to I3. Going on to I3. Again, we're going to look at this resistor. The minus side of it is the V. The negative side of this is the V. The positive side of it is the negative 10 from this battery. So this is minus 10. Right? So this is the minus 10 volts. Minus, what's the other side? V. Minus V. Over the resistance of 2000 ohms. And this is how you use Nodal to find your voltage at a specific point. And then you can just solve now for V to find out your final solution. And that's what we're going to do. Okay? So this equation, I'll just copy paste it down here. So now, if we simplify this, let us separate everything. First, let's distribute the minus into everything. So we are going to be left with the minus in the first one is going to become 10 plus V, all right, over 2000 plus V plus 5 over 1000 minus is going to be distributed, so it's going to become plus. When you distribute the minus, you just multiply everything inside by minus. So minus 10 becomes plus 10, minus V becomes plus V, all over 2000. All right, equal 0. So moving on, 10 plus V. All right, so 10 plus V, we can separate it into 10 over 2000. في شيء أحس غلط في الإيكويشن بس I'm not sure what yet. And everything is plus. Usually everything is not plus. Just give me a second. Let me make sure. Did I do my nodal right? Yes. Minus 10, 10. Yeah, okay. تمام. So 10 plus V over 2000 plus, this is V, so this is just where I'll keep it in red. So plus, here I'm just separating all of the values by themselves. So plus V over 1000 plus 5 over 1000 plus 10 over 2000 plus, again, V over 2000 is equal to 0. We're going to group our V's together and our constants together. So we're going to have V over 2000. We're going to have V over 2000. Plus V over 1000 plus V over 2000 is equal to, or let's just simplify it here, plus 10 over 2000 plus 5 over 1000 plus 10 over 2000. So 10 divided by 2000 plus 5 over 1000 plus 10 over 2000 is equal to 3 over 200. Okay? This is simply equal to 0. طبعا, you guys can simplify it easier if you just multiply everything here by 2000 from the beginning. It will simplify all of the fractions instead of doing it this way. يعني. And then I'll keep this down in a bit so I can just show you. If we multiply everything here on the left by 2000, and you multiply by the right by 2000 as well, anything you do to the left, you do to the right, but we have 0 here, so this is just 0. You're going to cancel out all of these. So you're going to have 10 plus V plus, this is V over 1000. So 2000 over 1000 is 2V. All right. Plus, again, this is 1000. So this is going to be 2 times 5, which is 10, plus 10 plus V is equal to 0. And then, يعني this is one way if you want to do it, but I will keep solving it in this way just to show you guys if you want to keep solving it this way what it will look like. فإذا طلعنا الحين هذا, we took it to the other side. This part, we took it to the other side. And we took the V as a common factor over here. So we have 1 over 2000 plus 1 over 1000 plus 1 over 2000 is equal to negative 3 over 200. All right. So V is simply going to be equal to, or we could just simplify this as well. So 1 divided by 2000 plus 1 divided by 1000 plus 1 divided by 2000. So it's going to be 1 over 500 over here is equal to minus 3 over 200. So we're just going to divide this both sides. We will get V is equal to 3 over 200, and minus 3 over 200 divided by 1 over 500, which is the same as minus 3 over 200 times 500 over 1. So V is equal to minus 3 divided by 200 times 500. يطلع لي negative 7.5. All right. For some reason in the mock test, it came out as negative 2.5, and I'm not sure why. Let me just check how they did it as well. Let me finish solving my part, and then I will check what happened in the mock test. All right. This is how you'll apply for KCL. And then this is how you will apply for KCL. You're going to look at your node. You're going to find your V over R's for each one, and then you're going to keep solving it until you find your V by itself, and you'll find the value for V. But again, the question was asking for what? The question was asking for the nodal analysis. Sorry, not nodal. It's asking for the currents, I1, I2, and I3 using nodal. So now we need to determine these currents, I1, I2, I3 in the circuit, now that we have given, or we have gotten the voltage. Then, so now that we have found this voltage, negative 7.5 V, we're going to look at this. Again, and now we can remove this V and put our negative 7.5 volts. And then we know that this is our voltage here at minus 7.5 volts. Okay. If we look at now each and every one of these currents, we have already found them earlier on using this equation of KCL. And then, so we know that this is our currents for each one. So now we just substitute for V for each one. So we know that I1 we know that I1 is this, we know that I2 is this, and we know that I3 is this, whatever's in the brackets without the signs. Okay, so this is I1, I2, and I3. I3 is purple. And then I3. For now, we could just substitute the value for V that we have found here. We can substitute it down. V is negative 7.5. So V is negative 7.5. Substitute this value now for V in each one, and you will find the current for each one. So I1 is going to be equal to minus 10 minus 7.5 over 2000. And then I2 is equal to minus 7.5 plus 5 over 1000. And I3 is equal to minus 10 minus 7.5 over 2000. All right. So if we just do the calculation here for each one, we get I1 is equal to minus 10 minus 7.5 over 2000, which is going to be negative 1.25 times 10 to the power of 3. All right. 10 to the power of minus 3, sorry, amps, or we can say minus 1.25 milliamps. I2 is equal to minus 7.5 plus 5 divided by 1000. So minus 7.5 plus 5 divided by 1000. I got negative 2.5 times 10 to the negative 3. All right, amps, or negative 2.5 milliamps. And for the last one, I3, so minus 10 minus 7.5 divided by 2000 is equal to minus 1.25 times 10 to the negative 3, which is simply equal to minus 1.25 milliamps. Again, if you notice, all of them are negative, so that means all of their directions should be reversed. And that's basically how you would solve with Nodal. All right, does this make sense? Any questions? Yes, you can assume your node to be anywhere. You can assume your node to be at the bottom or at the top. It doesn't matter. It's going to be the same exact way of solving. All right. But usually the bottom, we keep it as ground. So it's always easier to look at the top. And that's just a standard that is used. All right. As long as there are 3 currents, that is considered your node for nodal analysis. Okay, I noticed my mistake. And then I just noticed my mistake. So here again, current is going from plus to minus. It is a voltage drop. This is why this was negative, okay? Here, it's going from plus to minus. I don't know why I put it as positive, but it's going from plus to minus. Look at current I2. It's having a voltage drop. So this is going to be minus 5, not plus 5. This is why, so the mark is actually correct. I just noticed my own mistake. Here, it is a voltage up. I don't know why I was assuming current is going upwards here for some reason. But I even draw it downwards. But again, remember, current, when it's going from plus to minus, it's going to be a negative. If it's going from minus to plus, it is going to be positive. In this case, it's always going from plus to minus in all the cases. That's why it is negative, all right? My bad about that one. So this will be minus. So again, in our calculation, this will be minus. This will be minus. This will be minus over here. وبعدين معناته this one over here will be minus. أنا حسيت في شيء غلط، يمكن شيء كان plus. معناته here as well this will be minus. Here as well this will be minus. So this isn't 3 over 200 anymore. This is 10 plus 10 minus 5 over 1000. يطلع لنا 1 over 200, not 3 over 200. This is 1 over 200, which we'll take to the other side. So بيكون هني 1 over 200. This is 1 over 200 or negative 1 over 200. فهني بيكون negative 1 over 200. Negative 1 over 200. So minus 1 over 200 times 500. Yep, we get minus 2.5. هاي يسمونها تسطيلة آخر الليل. So we get negative 2.5 for our voltage. So again, our voltage is negative 2.5. زين. عشان تعرفون بس لو سويتوا غلطة بسيطة في الامتحان كيف بيكون إحساسكم. زين. ركزوا عدل في الامتحان عشان you don't do the silly mistake that I just did. So this is going to be minus over here. Actually, all of this is going to be different because voltage now is different. So let me rewrite the voltages. فالvoltage is minus 2.5. فهني minus 2.5. هني V, which is already minus 2.5. Minus 5. And here we're going to have minus 2.5 again. Minus 2.5. So when we find our final answer for each one, just let me recalculate all of it. Minus 10 minus 2.5 divided by 2000. هني طلع لي minus 3.75. Minus 3.75 times 10 to the minus 3 amps, or negative 3.75 milliamps. I2 طلع لي minus 7.5 divided by 1000 is minus 7.5 times 10 to the 3 amps, or minus 7.5 milliamps. I3 is minus 10 minus 2.5 divided by 2000. So it's negative 6.25 times 10 to the minus 3 amps, or negative 6.25 milliamps. Again, they're all negative, so they're all in the opposite direction. Okay. Again, the solving isn't that difficult. إنزين بس sometimes one small minus, شوفوا, one small plus and minus changes your entire question. فتake your time when solving. I know الوقت يكون شوي ضيق, ولكن take your time when solving. Make sure that you're solving it correctly rather than rushing and making a lot of mistakes. All right. إن شاء الله I'll upload this امتحان